Okay, we're going to do video number 9. This is on page 18 in the back of your book, and it is the homework part 6, predicting products for single and double replacement reactions. So here's the first example that's been worked out for you, potassium plus calcium chloride, and it's a single replacement. And so we're going to switch the potassium and the calcium. You have to verify all single replacements with an activity series. So we have to see, will this actually work? And you'll notice there is calcium and there is potassium. So potassium is the smile, calcium is the frown, chlorine is the star. And so this reaction does happen. And so when you predict your products, you get calcium and chloride here, and the calcium becomes the single element. So let's look at number 2 together. We have gold, which is AU, plus potassium nitrate. Potassium has a +1 and nitrate has a -1 charge, so they cancel. We have K and nitrate is NO3. So this is a single replacement reaction, which means you've got to use an activity series, which I have here. So the question is, will this reaction happen? And my gold is down here at the very bottom. That is the bottom of the entire list, so it gets a frown. And here's potassium almost at the top of the list. So it gets the smile, and nitrate is the star. And since our smile wants to be with the star, this is no reaction. We have zinc metal plus silver nitrate. Silver has a +1 charge and nitrate has a -1 charge. So those are going to cancel out. So silver nitrate is AgNO3. This is a single replacement reaction. So the question is, will this work? So we're going to go look at the activity series, and you're going to see zinc is here and silver is down here. So this has my smile, this is the frown, this is the star. So we are going to switch the zinc and the silver. So silver becomes the single element plus zinc becomes the element with nitrate, and now I've predicted my products. We need to make sure we have all the correct subscripts. So is this a diatomic? No, it's not, so it's good. Here, this has a charge of +2, that has a charge of -1, and so I'm going to crisscross, which is going to make this have a subscript of 2, and I'm going to put it in parentheses. So I put nitrate in parentheses, subscript of 2. I'm going to erase the charges because I don't need them anymore. And finally, we have to make sure that we have a balanced equation. So we're going to put our blanks in front for our coefficients. And so we have 1 zinc, 1 zinc, 1 silver, 1 silver, 1 nitrate, and I'll make this a little darker for us over here. That means we have 2 nitrates on the right side, and so I'm going to need a 2 here, which is going to give me 2 nitrates. But now I've changed my silver. I have 2 silver, so I'm going to put a 2 there. So it is 1, 2, 2, and 1. Okay, we have aluminum plus, and you don't know what sulfuric acid is, so it would be given to you, but it is H2SO4. And this is a single replacement reaction. So we need our activity series, and we want to look for aluminum and hydrogen. So here's aluminum, and here is hydrogen down here at the bottom. So aluminum is going to get the smile, hydrogen the frown, and sulfate is the star. So we are going to switch aluminum and hydrogen. So I'm going to put hydrogen by itself first, and then I'm going to put the aluminum with my sulfate. So sulfate is SO4, so it's going to be AlSO4. Okay, now on the right side, is this a diatomic because it's a single lonely element? Yes, it is, so it gets a little 2. And then I need to balance my charges. Aluminum has a charge of +3, and sulfate has a charge of -2. So that's going to crisscross. It's going to put a 2 there, and then I'm going to need to put sulfate in parentheses because it needs a subscript of 3. And so now I'm done with my charges. I'll erase them. And we can now balance the coefficients. So I'll put my blanks in front. 1 aluminum, 2 aluminums, so we need a 2 here. 2 hydrogen, so that's good. But we only have 1 sulfate here, but we have 3 sulfates over here. So that's going to put a 3 here, which has modified my hydrogen. 3 times 2 is 6, so 3 times 2 will make that 6. And so we are done with a 2, 3, 3, 1 ratio. This has chlorine plus potassium bromide. Chlorine is a diatomic, so it needs a 2. And then potassium is a +1, bromide is a -1. Those cancel, so this is just KBr. This, again, is a single replacement reaction, so we need our activity series, but this time the activity series is based off of the halogens, which looks like this. So basically we just look at the halogen family on the periodic table, and it goes F, Cl, Br, and I. And so chlorine is a halogen, so it's going to switch with bromine, possibly. Notice chlorine is higher than bromine, so it gets the smile, bromine gets the frown, and potassium is the star. And so we are going to switch the chlorine and the bromine. So our products are going to be the bromine is by itself, plus, and the K is going to be with the Cl instead. And now over here, is this a diatomic? Yes, it is. And then the charges of potassium is +1, chloride is -1. Those are going to cancel, so we're finished with our charges. And now we can balance our coefficients. 2 chlorine, 1 chlorine, that needs a 2 there. 1 potassium, 2 potassium, I'll need a 2 there. 2 bromine, 2 bromine. This is now balanced. It is a 1, 2, 1, 2 ratio. We have fluorine plus tin for iodide. Fluorine is a diatomic, so it needs a 2. Tin 4 means it has a charge of +4. Iodide is a -1. And so when we crisscross, that's going to put a 4 here. So now I need to use my activity series because this is single replacement. And so here they are. It's fluorine versus iodine. The fluorine is the smile, iodine is the frown, tin is the star. So these are going to switch. So iodine is going to become the single element plus, and this is going to be tin with fluoride. And it's still tin Roman numeral 4, just like it was at the beginning. So here, this is a diatomic, it needs a 2. And then tin is +4 and fluoride -1. Crisscross those, you're going to get a 4 subscript there. And now I'm done with my charges. So we'll balance the coefficients. 2 fluorine, 4 fluorine. So to fix it, I'll put a 2 here. 1 tin, 1 tin. 4 iodine, 2 iodine. And I'll fix it by putting a 2 because 2 times 2 is 4. So we have a 2, 1, 2, 1 ratio. So this time we have silver sulfate. Silver is Ag, sulfate is SO4. Silver has a charge of +1, sulfate is -2. Crisscross means I need a 2 here. Plus aluminum chloride. Aluminum's +3, chloride is -1. We'll crisscross those, and so this will get a 3. And this is a compound plus a compound, which makes it a double replacement. So in a double replacement, it's going to be first with last. Don't use the subscripts unless it's part of a polyatomic, which these are not. These are monoatomic. So it's going to be just Ag and Cl plus third, which is aluminum, and second, which is sulfate. Sulfate is a polyatomic, so that 4 does come over to the right. It's going to be SO4. Now, on the right side, I have to balance my charges. Silver and the chloride are +1, -1, which cancel. The aluminum is +3 and the sulfate is -2, so we're going to crisscross. That's going to put a 2 here, and the sulfate, we're going to have 3 of them. And so now I'm finished balancing my charges. We'll balance the coefficients next. So we're going to get a blank here, a blank here, a blank here, a blank here. 2 silver, 1 silver, that puts a 2 there. 1 sulfate, 3 sulfates. So I'm going to need a 3 here. That has changed my silver to 3 times 2 is 6. So I'm going to go ahead and change this to a 6. And so we have 3 times 2 is 6. 6 silvers. 3 sulfates. 3 sulfates. 1 aluminum, 2 aluminum. So I'm going to need a 2 here. And then 2 times 3 is 6 chlorine, and this gives me 6 chlorine. And so this is balanced 3, 2, 6, and 1. Now we're going to determine which of these 2 products is a precipitate by using the solubility rules. So notice that silver chloride, we have chloride is what I want to look for, which is there. And chloride is soluble except with silver. So that's going to make this an insoluble compound, insoluble, which makes it the precipitate. And so that's our precipitate. You can see that sulfate here is soluble, and aluminum is not an exception. So this is a soluble compound, which is not the precipitate. Lead 2 nitrate is going to be Pb for lead, and nitrate is NO3. We have plus 2 minus 1. So when you crisscross, that's going to make this parentheses 2. Plus magnesium and iodide, plus 2 minus 1, crisscross puts a 2 here. Is this a double replacement reaction? So we're going to put first with last. Do not carry this 2 over. So lead and iodide, plus third and second. Third is magnesium. Second is the nitrate in the parentheses, NO3. And now we're going to balance the charges on the right side. The lead is plus 2 and the iodide is minus 1. So plus 2 and minus 1 will crisscross. That's going to put a 2 here. Magnesium is plus 2, nitrate is minus 1. So we're going to crisscross those, and that's going to put nitrate in parentheses with a 2. So I'm done with my charges. And now we can balance the coefficients. So we're going to put a blank here, blank here, blank here, blank here. 1 lead, 1 lead, 2 nitrates, 2 nitrates, 1 magnesium, 1 magnesium, 2 iodides, 2 iodides. So everything is balanced. 1, 1, 1, 1. Now, finally, use your solubility rules to determine which of these 2 products is a precipitate. And so if we look here, we can find iodide is there, and that is soluble except with lead. So because this is lead iodide, that makes this our precipitate. Number 9, sodium hydroxide, it's OH. Sodium has a plus 1 charge, hydroxide has a minus 1, so they cancel. Plus iron 3, and nitrate is NO3, and this is plus 3 minus 1. Crisscross them means that we need a 3 here. So this is a double replacement, which means it's going to be first and last. We are not going to carry this 3 in parentheses, just the NO3 inside the parentheses. So it's going to be Na, NO3, plus third and second, so this is iron and hydroxide. And now we're going to balance our charges. Sodium has a plus 1, nitrate a minus 1, so those are going to cancel. Iron is plus 3, and hydroxide is minus 1, so we're going to crisscross, and that's going to give me parentheses and a 3 around the hydroxide. So now that we've balanced our charges, we can balance the coefficients. So I'll draw my blanks you have 1 sodium, 1 sodium, 1 hydroxide, 3 hydroxides, so we need a 3 here, 3 sodium, 1 sodium, so that's going to need a 3 there, 1 iron, 3 nitrates, and this is 3 nitrates, so we are now balanced. It is 3, 1, 3, 1. You need to use your solubility rules to determine which of these is the precipitate. You'll notice that nitrate is there, and it is soluble with no exception. So this is not the precipitate. Here, I'm going to look for OH, my hydroxide, which is there, and hydroxides are insoluble, and iron is not an exception. So that's going to mean this is our precipitate. 10, aluminum is Al, sulfate is SO4, plus 3 minus 2, and you're going to crisscross, so this should get a 2, this should get a 3, plus ammonium, haven't seen that one in a while, no hate for the positive ones, is a positive 1. Nitrate, NO3, that's got a negative 1 charge. So this is crisscross, these cancel, and there's my reactants. This is a double replacement, so we are going to do first and last. Do not carry this little 2 because this is not a polyatomic. So it's just going to be Al, but last is a polyatomic, NO3, so you are bringing the 3 to the right-hand side, plus third and second, another polyatomic, NH4, so bring all of those, the 4 included, and then second is sulfate. SO4 is sulfate, the polyatomic, so we're going to bring over the S, the O, and the 4. So now we can balance our charges. We have a plus 3 minus 1 on aluminum nitrate, so crisscross is going to put that in parentheses with a 3. This is a plus 1 minus 2, and when I crisscross that, I'm going to get ammonium, and I should have 2 next to ammonium. So we're done with our charges now, and I don't erase them always, but we definitely don't need them anymore, that's for sure. Now I can balance my coefficients, so I'm going to put my blanks in front. We have 2 aluminum, 1 aluminum, so that's going to put a 2 here. We have 3 sulfates, 1 sulfate, so I'm going to need a 3 here. We have 1 ammonium, 2 times 3 is 6 ammoniums, so we need 6 there. And then we have 6 nitrates, and look here, 3 times 2 is 6 nitrates, which is already balanced. So this is going to be 1, 6, 2, 3. Now we identify our precipitate. So if I look here, nitrate, NO3, is there, and it is soluble with no exception, so that cannot be my precipitate. And then here, sulfate, SO4, is there. It is soluble, and except with these compounds, but since ammonium, NH4, is not one of the exceptions, both of these are soluble. They're both soluble. This actually can be labeled no reaction because we don't get a precipitate, we don't get anything. They just both remain dissolved in solution. Last one, number 11, we have calcium nitrate. Calcium's plus 2, nitrate is a minus 1. When you crisscross, we'll get 2 nitrates plus sodium and carbonate. Sodium is a plus 1, carbonate is a minus 2. Crisscross means I need a 2 here. Yields. This is a double replacement reaction. So we're going to do first and last. First is calcium, last is carbonate. It's a polyatomic, so that 3 does come over to the right. So CO3 plus third and second. So third, sodium's not a polyatomic, so don't carry over that 2. It's just going to be Na, And then second is the nitrate, and we want just what's in the parentheses, NO3. So we'll put NO3 here. Now on the right side, we need to balance our charges. We have +2 minus 2 are going to cancel, and this is +1 minus 1, and those are going to cancel. So my charges are now balanced. Finally, I need to balance my coefficient. So it's going to be 1, 1, 2 nitrates, 1 nitrate, so I'm going to put a 2 there. 2 sodium, and now this gives me 2 sodium, 1 carbonate, 1 carbonate. So this is going to be 1, 1, 1, 2. And lastly, we need to identify our precipitate. And so I'm going to look at CO3, and CO3 is down here under insoluble, and calcium is not an exception. So this one is our precipitate because it is insoluble. And now we are finished.